Recording in progress.
Yeah, come on everyone, let's start off. The last thing that we did was the sphere and the block, and then we did this graph question. Let's go ahead, let's do a few more, and then we'll start off with vertical circular motion also today. Other scans on? Let's start with the standard one. Let's say we got a hemisphere. This is fixed, smooth hemisphere. The radius is r. You placed a block on top of it, and it is gently disturbed. Then what will happen? This block will start sliding on this. So this block will slide, and then at some point it will lose contact and falls on the ground. A block is gently displaced or gently disturbed. Find the angle when it loses contact with the hemisphere and the position where it lands on the ground. The first one is a standard question. Find theta when it loses contact. Others, keep your cams on and find the position where it lands on the ground. Let's get this. Yeah, the first part is easy. Let's see the first part. So when it is losing contact, draw the FBDC. When you say you're losing contact, meaning normal reaction becomes 0. This is theta. This is the block M. What are the forces? You have your mg. You have your normal reaction. Since you're going in a circle, there is a centrifugal force mv square by r. If that is theta, this is theta. So mg components will be mg sine theta and mg cos theta. So normal reaction plus centrifugal force minus mg cos theta is 0. When it loses contact and becomes 0, means you get V is equal to root over Rg cos theta. So when this block gains this much speed, it loses contact. So when it loses contact, initially the block is here. This is my state 1. The block is losing contact here. This is my state 2. This has speed V. If you look at this height here, this is R, so this is R cos theta. This will be R minus R cos theta. So I can write loss in potential energy is equal to gain in kinetic energy. So here the loss in potential energy will be mgr1 minus cos theta is equal to half mv square. Mm cancels off. We get gr1 minus cos theta. What is v square? V square is rg cos theta. Rg cancels off. You end up with cos theta is equal to 2 by 3. Standard result, mains or CET or this well or MIT ka exam ka result. Question still not over. Now after losing contact, this thing will start flying and fall on the ground somewhere here. So what is that position? You can measure the distance from the center. It becomes a projectile motion question now. Let's get that. And did you observe this thing? This answer is independent of the radius. You take a big sphere or a small sphere. You take big ball or small ball. It doesn't matter. This is what will happen. This is the reason when you go to a park, they will never make a slide like this. They will always make slides like this. If you make a slide like this, the kids will fly away from here. You don't want kids to start flying in air, isn't it? So that's a bad design for a slide. How do you find the range? Get it? It's a little more complex with the numbers, but try. I'll give you a minute. So cos inverse 2 by 3 is when it loses contact. So what position will it land on the ground? Let's see. I think my numbers are bad. We'll just write the equations and leave it if the calculations are too tough. So this is theta. This height will be r cos theta, which is nothing but 2r by 3. This block is there. This is going with velocity v, which is root over rg cos theta Cos theta is 2 by 3. So this is 2 root rg by 3. So this whole question has become as if there is a building. The building ka height is 2r by 3. And someone is throwing a particle here with speed v like this. What angle is that? This is the tangent. This is theta. This is theta. This is 90 minus theta. So this will be theta. Isn't it? That will be the theta. Basically, this is theta, and this velocity will 90 minus theta. So with the horizontal, it is theta. So horizontal component will be v cos theta. Vertical component will be v sin theta. Yeah, numbers will be bad. Then we can use for time of flight Sy is equal to uyt plus half ayt square. Hope you remember how to do projectile motion from a building. This will be minus 2r by 3. This will be minus u sin theta because you're pointing downward. Signs are important. You go for a sign, the whole thing will go for a toss. And this is minus half gt square because gravity is down. Yeah, that sin theta is bad, I guess. What will be sin theta? Cos theta is 2 by 3, root over 1 minus 4 by 9, root 5 by 3. So from here, if you solve, you'll get time. Then you get range is equal to v cos theta into t. So this will give you answer from this will be the range which we'll get. Let's leave it like this. Calculations are bad. But I hope you know how to proceed with this. Clear with the steps. Once you got the velocity and the angle, it becomes a projectile from a building. So any doubts on this? Same thing. Let's do another variation of this. Let's say we have a smooth incline. Now this is free to move. Same story, you kept the block on top of it. But this time the wedge is moving with a constant acceleration. So someone is accelerating this wedge with constant acceleration. Constant acceleration of hemisphere.
So during its entire motion, right?
Yeah. Why? What kind of doubt is that?
I mean, वो ब्लॉक जब मूव करना स्टार्ट करा तो एक्सेलरेशन चेंज हो सकता
क्यों change होगा? A is constant. Why will I write constant then? Exam में no one will explain you, right? They'll simply write this word and leave it. Don't overthink so much. Then I won't use the word constant, no? Then I would say the block is released. Why will it go on its own without any acceleration?
है.
Question to suno na. So same question. Find theta when the block loses contact. How will you handle this? I hope the question was clear. The wedge is moving. And remember, whenever you use constant acceleration, I told you something last class. If you guys remember, that is the reason, wordings are important. When any system goes with constant velocity or acceleration, let the observer be on the system. Do you remember the statement? So when you learn something, don't think it is only for that question. That concept can be framed anywhere. Again, this is not a concept, but just an observation. That means what you do, go and stand on the hemisphere. Now what will happen? Hemisphere will come to rest. Now there is a pseudo force ma backward. So the pseudo force is dragging the block down. Now solve. Just write the equations and leave. If I give a value, it will be easy to solve. Just get me the equations. So keep that in mind. If something is going with constant velocity, constant acceleration, generally, most of the times, if you go and stand on that frame, your life becomes easy. Now try. I'll give you 2 minutes. Wow, you got a number. You got an answer without A. Interesting. Let's see. So let's keep the observer on top of the hemisphere. So my observer is standing on this. So basically, it is a non-inertial frame. So what are the forces acting on this? Now there'll be a pseudo force ma. There will be normal reaction. There will be mg. And let's say you're also going with speed v. Again, remember this v is the speed with respect to this observer. So you will also have a centrifugal force mv square by r. These are all the forces. This is angle theta. This is theta. So if I just draw this thing again, this will be mg cos theta. And this will be normal reaction. This will be mg sin theta. This will be ma cos theta. This will be ma sin theta. So I have to resolve the pseudo force into components and the centrifugal force. So your normal reaction will also have a centrifugal component. So we'll have n plus ma sin theta plus mv square by r is balancing mg cos theta. N is 0 since it loses contact. So you end up with a sin theta plus v square by r is equal to g cos theta. Keep this as one equation. All clear with this? I hope you got the FBD part right. How many variables are there here? We don't know theta, we don't know v. There are two variables. I need one more equation. The second equation comes from conservation of energy, meaning law of work energy theorem. Again, my observer is standing here. So initially block is here. This is my state 1. Finally, the block is somewhere here when it loses contact. This is theta. This is my state 2. So what are the forces? MA, pseudo force is acting. That is your external force in this frame, the pseudo force. Normal reaction will not do any work. Mg is fine. That is an internal force. So this displacement will be r sine theta. And this height will be r into 1 minus cos theta. Perfect. So work done by pseudo force will be final energy minus initial energy. Work done by pseudo force is constant, that is ma into displacement, ma r sine theta. Final energy is half mv square. I will take this as reference line, and initial final potential energy is 0. Initial potential energy mgr 1 minus cos theta. This gives you the second equation. Numbers are you need to find theta, so I need to get v square from here and substitute here. So v square by r take this and bring it here. AR sine theta R gets cancelled. G, nothing gets cancelled actually. AR sine theta, and that's also AR by 2 sine theta, so that will be 3 by 2 AR sine theta. This is RG cos theta, and that is 3RG by 2 cos theta. And that's minus GR. That's it, meaning you have to, then it will become complex to solve. You can leave it here. If they give you Eka value, you can do something about it. This will be your final answer, and from here we'll get somehow theta if Eka value is given. Clear with the steps? It does depend on Eka value there. So if A is equal to G, I think then it becomes easy to solve. If A is equal to G, then everywhere RG will cancel, and then you'll end up with a decent equation. You will get sine theta minus cos theta is equal to 2 by 3. Something of minus 2 by 3, something of that sort you will get. Clear? If you put A is equal to 0, you will get the previous result. This is your second equation. Any doubts on the steps? First thing is your force equation. Second thing is your work energy theorem. So basically, the pseudo force is making you, increase the speed, and that's what is happening there. R cancels actually. This will be 3a sine theta, 3g cos theta minus 2g. Leave it like that. We will not solve this. Actually, we can solve. You can write that sine theta is root over 1 minus cos square theta, and then square on both sides. Then you get a cos theta ka quadratic, and then solve. It can be done. Let it be. All clear with the steps. Let's see one more. The first one is a standard question. We have a hemispherical pipe, cylindrical hollow hemispherical pipe. Inside this pipe, you kept two spheres. I'm exaggerating the figure. It's actually pretty thin. This is better. This is the radius r. We have two spheres on the top, mass m and mass m. They're both released from the rest. Capital M is the mass of that semicircular pipe. Now, when you release them, what will happen? Something happens, and they will, the balls are loosely fitted inside. As they start coming down, they start actually pushing this hemispherical, semicircular pipe outside. Balls are loosely fitted. So this is how the picture will become. When these balls start falling at some particular angle here, let's say this angle is alpha, let's say this angle alpha, this thing just lifts off the ground. This thing actually loses contact. Getting it? This pipe lifts off the ground. Now you need to understand why it will lift off. The pipe just lifts off. So the first question, find alpha when the semicircular pipe just lifts off. Second thing, find the condition, find m by m if the pipe never lifts off or if it lifts off. There's a condition, this pipe will always not lift off. There is a certain value of m by m. If it exceeds that, no matter what you do, this will not lift off. And neglect the size of the balls compared to the radius. You can treat them as point objects. I hope the picture is clear. So as these balls start coming down, think for a minute, then I'll tell you what is happening and then I'll give you some more time. First, understand why the hell this is even trying to lift off. Try to get a context, what is happening with the whole thing. See what is happening with the context. So that is important. First of all, you need to understand. See, most people need to see the question, don't run behind the answer. You can do that in the exam. Are you getting it? In the exam, run behind the answer. But outside the exam hall, when you're trying to solve a question, don't worry about that. Always try to understand and try to figure it out. Be curious like a kid. Oh, why it is happening? Why is this happening? And if you're not getting a question, instead of getting scared, be happy that you're getting something to learn. So when you are like that, right, then when you see a question, you won't panic. Your brain will freely think. And once you get used to that, right, in the exam, you can worry about the answer. Problem is that when you see a question, you think you should get an answer. I said, why the hell should you get an answer? Let it be, na. It's completely fine if you don't get an answer. Spend time in thinking and understanding. Meaning, if you even had figured out why the hell this is going up, I think you did a pretty good job. So look at the scenario. As these two balls are coming down, this is something what will happen. I think I'll draw this a little big. These balls will actually start pushing the outside because of the centrifugal force. And why do you get that? Remember, just now we solved a question. Up to cos inverse 2 by 3, you will be touching the lower part of the pipe. After cos inverse 2 by 3, you'll be touching the outside of the pipe. So if you look at this ball cut trajectory, this is what you will notice. So initially, the ball will be touching the lower part of the pipe till cos theta 2 by 3. That's what we have derived. After cos theta 2 by 3, this ball will start moving on the outer edge. Is that making sense? So up to cos inverse 2 by 3, right, the balls touch the lower surface. And after theta, they touch the upper surface. Think about it. In the hemisphere problem, what happened with the ball? The ball lost contact, isn't it? But now if you have a cover on the top, what will happen? You'll go and hit that cover on the top. Alpha is not given there, Ishma. Need to find that also. And after theta, it touches the outer layer, the upper surface. And because you're touching the upper surface, if you actually draw FBD of the pipe, this is what you will notice. If you just draw FBD of the pipe, this point there'll be a normal reaction. This point there'll be a normal reaction. And there'll be a gravity mg acting downward. So the two NCA components are pushing this thing upward. That's why you lost contact with the ground. I hope the whole context is clear now. So as these things are coming down, they'll increase in speed. As the speed increases, at some point, they'll lose contact with the lower surface. They'll go and hit the upper surface. Once you hit the upper surface, you're pushing that semicircular pipe outward. And since there are two balls, both are pushing with N and N, the vertical component is balancing mg. That is the reason this thing is lifting off the ground. Clear with this? Now how to do? Try. I'll give another 2 minutes. So what I'm teaching you is not only the question, I'm also teaching you how to handle a question when you're practicing at home. What you guys do, you see a question and you just keep thinking about the answer. Take your time, na? Matlab, socho, kya ho raha hai, kyun ho raha hai, and then again think. Step by step. You got stuck, that is fine. So when I tell you solve a question, when you're solving questions at home, you can spend maybe like, if it is a tough question like this, you can spend 8 to 12 minutes on this question. If you don't get anything, that is fine. Leave it for the day. Next day, try again once more. If you're still not getting, then you should come and ask for doubts. You can ask anyone. You can ask me, you can ask your friends, you can ask your class teacher. It doesn't matter. Get your doubt cleared. That's the most important thing. But before that, you should try at least 2 times on 2 different days. Your thinking is more important. If you, without trying, if you get an answer or a solution right, your brain will become too lazy. It will never think. You'll never become strong. Try. Anyways, give it a try. Now you got the idea there. I'll give another 2 minutes. So at an angle alpha, try to draw the FBD, find the velocity, and try to get that normal reaction. Anyone still confused here? Anything that you didn't understand, please ask. Six m cos alpha. You can find alpha right, from there, Samyak. Just put the equal sign, quadratic equation ho jayega na, then find the roots from there. And once you get the roots, remember cos alpha ka value must be less than equal to 1. Or the roots must be real. That will give you the answer for the second one. Both are related. If you don't get the first one, you won't get the second one. Let's see. These are the kind of questions, where you can get stuck for 1 or 2 days. And that's completely fine. You try on day one for 10, 12 minutes. You don't get it, leave it. Don't waste more than 10, 12 minutes on a question. That too, a tough question like this. A normal HCV starting level questions, you should not spend more than 4 or 5 minutes. And if you're not getting it after 10 minutes, leave it for the day. Take a break, do something else, do other question. Next day, again, think about it for 4 or 5 minutes. Trust me, most of the questions you will get it. When you leave it for a day, your brain will actually figure out how to solve. The thing is, we are so impatient, we want the answer immediately. You're not giving your brain to think only about it. Now, if you do that, the problem is you will be slow. You won't be able to solve too many questions. That's okay. That's seriously okay. Matlab, even if you do every day like 10 questions, in that there are 2 to 3 questions of this level. You have to do some tough ones every day. In a week, maybe if you're doing 5 days a week physics, you will do maybe 50 to 60 questions. For 2 weeks, you will do 120 questions. But you're doing them properly and understanding this. That's the reason I keep telling you, do only 2 books. Your classes ka material and choose another one good book. Done. Don't try to run behind too many materials. Because when you run behind too many materials, you want to solve a lot of questions, means you're not thinking properly. And once you become strong, then speed will come afterwards. Problem is we all want to be speed. We all want to be fast. No one wants to spend time and becoming strong. Next time, when you get a chance to watch this 100-meter race, Usain Bolt and all, watch that video. Look at how his body looks. He has big muscles, and if you see his thighs and all, they're huge and big muscles. He spends a lot of time strengthening his muscles for a 10-second race. That is how you get speed, when you're strong, not when you just keep doing, lot of simple questions. There. So this is your alpha there. So what are the forces acting on this? So there is a normal reaction which is pushing down because you're touching the outer surface. Your own mg ka component, how much is that? This is your mg. That will be alpha. So this is mg cos alpha. Your centrifugal force is pulling out. So mv square by r. So we have normal reaction will be mv square by r minus mg cos alpha. This is your normal reaction. So initially the balls were here. This is my state 1. This is my state 2. So this height difference will be r cos alpha. This height difference will be r into 1 minus cos alpha. So loss in potential energy is equal to gain in kinetic energy. R into 1 minus cos alpha. I remember, because both the balls have same mass, this big one will not move. So you can treat them at rest for now. Loss in potential energy is equal to gain in kinetic energy. That would be mgr 1 minus cos alpha is equal to half mv square. So take mv square from here and dump it in the equation 2. You end up with n is equal to 2 mgr 1 minus cos alpha minus mg cos alpha. So we get normal reaction. This r won't be there. mg 2 minus 3 cos alpha. You can clearly see when n is 0, you'll get that cos alpha 2 by 3 thing there. You got your normal reaction. Now if you draw the FBD of this semicircle thing, this normal reaction is pushing out. This normal reaction is pushing out, and your weight is capital Mg. Remember, it's only pipe ka FBD, so you will not take balls ka mass. This is alpha, this is alpha. Since you want to just lift off 2n cos alpha, the vertical components must be equal to capital Mg. 2n cos alpha is nothing but 2 into this is small mg. This will be 2 mg 2 minus 3 cos alpha into cos alpha is capital Mg. This will be 2m 2 minus 3 cos alpha is equal to capital M. 4m cos alpha 6m cos square alpha is equal to capital M. You get a quadratic in alpha. So then get the roots for this. The answer will come in terms of capital and small m, that is given. 4m plus this will be 16m square minus 24m small m by 12 small m. You get this thing. That's your cos alpha. Now the roots have to be real. The discriminant delta must be greater than or equal to 0. So 16m square minus 24 capital M small m must be greater than or equal to 0. We get 16 small m is greater than or equal to 24m. So we get m by m must be less than or equal to 2 by 3. That means in the reverse, if you think about this, if m by m is greater than 2 by 3, the pipe will never lift off the ground. That is how you can interpret. Have a look at this. Clear with this?
So can you show the last page for a second?
Yeah. This is the main thing actually, the FBD. Draw the FBD of the balls, conservation of energy, then draw the FBD of the pipe. Have a look at the steps. Ask me if you're not clear with anything here. Anything that you're not clear in this FBDs, please ask.
Done, sir.
Any other doubts in this page? Check out this page. And this is just solving anyways. Okay, let's see. Cos alpha. Okay, you simplified it further, okay? Okay. Next thing, vertical circular motion. Now this is also an important part. So listen to this thing. So consider a pendulum of length L. And mass m free to move in a vertical circle. This is also important. HSE image is the full derivation in 12th standard in a vertical plane. So let's see what are the issues with this. So you take a string, you fixed it at one end. This is mass m. Now, if you just give some velocity u to this, you will notice when you're in the lower quadrants or the lower hemisphere, no matter how much this thing swings, look at the forces. We have tension T, we have mg cos theta, and then we have centrifugal force. You will notice the tension is mg cos theta plus mv square, well, meaning tension will never be zero. So basically in lower hemisphere, tension can never become zero because both are acting in the same direction. String will be always tight. The problem starts once you go into the upper quadrants. So once you're in the upper hemisphere, Let's say if you take this as theta. Now if you try to draw the forces, the tension is pulling you down. The mg ka component is also pulling you down. The centrifugal force is pulling you out. That means the only one who is trying to keep the string tight is your centrifugal force. So we get tension is mv square by L minus mg sine theta. You're getting it? Now you will notice as you start going up, as the particle goes up, particle will slow down. As the particle goes up, V decreases. That means the one person who is the one force which is actually keeping your string tight is becoming weaker and weaker. Getting it? As the particle goes up, V decreases. Therefore, the centrifugal force mv square L is decreasing. So this is the guy who is keeping your string tight, and it is becoming weaker. And that mg sine theta is actually messing up and trying to make the string loose, and that is becoming stronger. As you go up, theta increases, sine theta tends towards 1. So means if you see the story here, in the fight that is happening, the centrifugal force is trying to keep your string tight, and your mg sine theta is trying to put your string down. And the one who is trying to keep your string tight is becoming weaker, and the other guy is becoming stronger. The typical movie top plot, right? The hero keeps becoming weaker and weaker and weaker, and the villain is becoming stronger till the interval. After the interval, something happens to the hero. So something of that sort. Now, at the highest point, your centrifugal force is the weakest. And at that point, your mg sine theta is the maximum, it is strongest. So basically, this is your just before the interval or climax before that scene. So now think about like this. So at the highest point, if your centrifugal force can somehow balance your mg sine theta, right? What will happen after that? Once you cross the highest point, the speed will again start increasing. So your centrifugal force will again become stronger, and mg sine theta will again become weaker. That means somehow if you can survive at the highest point, then you will survive everywhere. Does that make sense? If your weakest centrifugal force can balance the strongest mg sine theta, that means the centrifugal force will always be greater than mg ka component. String will never become loose. So if you look at the highest point, now if you try to look at the forces, the tension is trying to pull you down. The mg has become completely strong, and the speed will be mvh square by L, the highest thing. So at this point, your speed is vh. So we have T plus mg is equal to mvh square by L. So for tension to be greater than 0, we will get mvh square minus mg. So if this is greater than 0, then you get vh is equal to root gl. That means if you want to safely complete a circle, you need to have at least this much speed at the highest point. Getting it? This is the minimum speed at the topmost position so that the string doesn't become slack. Meaning tension becomes 0 momentarily, but next moment again your speed will increase, string becomes tight. So this is the minimum speed at top in order to complete a vertical circle. That's it. This is the whole theme in the vertical circular motion. At the highest point, your speed won't be 0. That's it. You need to have some speed or else you won't go in a circle. Then, so at the lowest point, your speed will be some u. So I can conserve energy, state 1, state 2. So at the lowest position, potential energy is 0. Kinetic energy is half mu square. At the highest point, potential energy will be 2 mgl because the height is 2l. This is L and this is L. Your kinetic energy is half mvh square. Energy in state 1 is equal to energy in state 2. We get half mu square is equal to 2 mgl plus half mvh square, but vh ka minimum is gl. You end up with u must be equal to root 5 gl. this is your minimum speed at the lowest position. Therefore, u must be greater than or equal to root 5 GL at the lowest position to complete a vertical circle. This is your standard result. If you give anything less than this, the string will become loose in the middle. It won't even complete a circle. Please have a look at this page. I hope the story is clear what is happening. As you keep going up, your centrifugal force and mg ka component are fighting. As you go higher and higher, your centrifugal force becomes weaker. Mg sin theta becoming stronger. So your mg sin theta is making your string, weak, loose. So if you don't have enough speed, you won't even go to the topmost point. So if you reach the topmost point, there the minimum case is where your centrifugal force just balance the weight. That gives you VH must be equal to at least root GL. Now using this to conserve energy from the ground frame, you grab the lowest frame, you get root 5 GL. Check the steps. So what happens if your velocity is less than root 5 GL? Let me show you that in the next page. But any doubts on this page, please ask me. So this whole vertical circular motion story is this only. At the lowest position, at the highest position, you cannot have zero speed. So this is how it would look. So this is the string. And let's say you are given speed u, and let's say the speed is less than root 5 GL, means you didn't give the minimum required speed. Then what will happen? You will continue to go in a circle. Like I said, you won't have a problem in the lower quadrant. You will not have a problem in the upper quadrant also for some angle. So you will go till here. At this some particular angle here, tension becomes 0. And after this point, you will start going in a parabola, like a projectile motion. If u is less than root 5 GL, the string becomes slack. Actually, we will show you this should be u is greater than root 3 GL, or else you won't even go to the upper quadrants. 2 GL. And less than root 5 GL. Then this is the picture you will see. This is how the path would look. Yeah, no, both are minimum only. VH is the minimum speed at the highest point. Root 5 GL is the minimum speed at the lowest point. Both are minimum speeds, but one is at the highest point, one is the lowest point. Basically, if you give here minimum, here also you'll get minimum, na? Got it? Well, let's see how this would look. I think I should have something to show you. Let me see.
Motion. Objective. To study the dynamics of vertical splits in extensive other of push
pendulum string, blah, blah,
a
blah.
circular path at A. The bob takes a circular path of radius L in the vertical plane. Let's divide the circular path the bob may take into 4 quadrants around point O, 0 to 90 degrees, 90 to 180 degrees, 180 to 270 degrees, and 270 at point O theta.
This is what I showed you. When you're in the lower quadrant,
Can be perpendicular.
mg cos theta, centrifugal force, both will always add up.
Initial
The tension will be mv square by L plus mg cos theta.
mg cos theta.
So you will never become loose.
But from zero,
The problem is the lower
string
quadrant. So look at this picture. Huh?
point. When the bob progresses into the second quadrant, tension in the string gradually decreases and becomes zero at some point.
Can you see that path? This is what I was saying. If you don't give enough speed, there is a possibility that tension becomes zero, and you can see how the string is. The string has become loose. That is how the picture will look.
When tension in the string becomes zero, the string becomes slack, and the bob undergoes projectile
There,
motion
it
from
becomes
this point
again tight.
onwards.
It goes in again a partial circle, and this just keeps repeating. Actually, when the string becomes tight, you will lose some energy if it is an
Minimum
inelastic
initial
string.
friction. Consider the
We'll
case
not get
at
into
the
that.
point 180
So if you want to
degrees
complete the vertical circle,
and
same
the
story. At the highest
lowest
point, you
point,
need to have all that
half
story.
not square.
I hope clear with that picture there, how the string becomes loose. Clear with that, everyone. So let's see if I have that photograph. There, this is how the picture will look. This was that string. The string has become loose. Clear with this. So that's the whole theory of this thing. Take a break. Come back by 9:40. We'll continue from here. Any doubts so far? Chalo, come back by 9:40 then. Mm. Yeah, let's start off. Now, look at this thing. So let's say at the bottom you have given a speed u greater than root 5 gl. Then when you're at this position, your speed will be root over u square minus 2 gl. At the topmost position, your speed will be root over u square minus 4 gl. So the speed changes. This comes from conservation of energy. At the highest point, the tension will be T2. At the lowest point, the tension will be T1. At highest point, you have mg downward, you have tension, I'll call it TH, and the centrifugal force mv square by L. At the lowest point, I'll call it TL. Your mg is also downward and the centrifugal force is also downward. So tension at the lowest point, mg and mv square by L will add up. If you actually subtract the difference in tension at the lowest point, minus tension at the highest point, this thing, interesting, the answer will be always constant. This will be always 6 mg. Remember the result. This is for u greater than root 5. It doesn't matter with what speed you throw as long as it is greater than root 5 gl. The difference in tension will be always 6 mg. And this was a straightforward question in the exam. What is the difference in tension in a vertical circular motion? Check this out. Clear with this? Just a few results there. That is one good result. Just calculate, Naresh, Srihari. Substitute the values now, VL, VH and solve. How kya? Why are you so lazy? Just subtract and solve. I wrote all the equations for you. Please don't think this is school. School mein teacher will write each and every for you. You're preparing for advance. So that is u square minus 4gl. This is u. Substitute here and subtract them TL minus TH. How difficult is that? Not your fault. Unfortunately, school mein, I think the spoon fed you guys so much. You guys think like you should remember everything. Don't need to remember everything. Learn to derive. Now, what if you replace the string with a rod? How does that affect the problem? If you replace string with a rod, then see the advantage of a rod, right? A rod can push and pull. So at the highest point, you can come momentarily at rest. A string can only pull, it cannot push. So at the highest point, right? You won't be able to do that. Yeah. Since rod can push and pull, at highest point, the ball can come momentarily at rest. At topmost point B can be 0. So what happens here? This rod is, instead of pulling, it is actually pushing T, and this is mg. String cannot do this. String cannot push. Now when you give speed here, again state 1 and state 2, energy in state 1 is equal to energy in state 2, half mu square is equal to mg. The total height is 2l. U is equal to root over 4gl. So therefore, the U minimum when it is a rod is root 4gl. So be careful. Are you talking about a rod or a string? If it is a string, root 5gl. If it is a rod, it is root 4gl. Clear with this? That's the whole theory of this vertical circular motion. So the main concept in vertical circular motion is, if it is a string, at the highest point you can't have a 0 speed, you need to have at least root gl so that you can complete a circle. That's it. Once you figure that out, everything will fall in place. All clear with this? Let's see a few questions on this. So let's say we have a track like this. Ever seen that Hot Wheels car track? Something of that sort. So this is the track of radius r. The whole thing is smooth. This is 30 degrees. This is A. C is the topmost point. This height is h. So we have a ball here of mass m released from rest. First question, find h minimum. This is a standard equation to reach point C. Second question, if h is equal to 2 times h minimum, that means if you give 2 times the minimum height required, you will definitely complete the circle. Find the acceleration of the ball and normal reaction at point A. So when this ball reaches at point A, and normal reaction. This is a decent question, but the same question, remember, again, I'll ask you this in rotational mechanics. In rotational mechanics, this ball will not only slide, it will roll also. That would be a much better question than this. So, but yeah, this is the basis for that. Let's try this. Naresh, man. Again, you're doing the same mistake. At the highest point, if your velocity is 0, the ball won't even reach there. It will go and fly like this. Nah, you won't reach the topmost point. This is just like a string ka case. Right, Ishwan. The first case is easy. Yeah, first one is easy. Right, Anvita. First part is easy, everyone. Everyone should be able to get that. Second part, right, Utsav? G by 2 root 199. Interesting. Let's see. Anyone else got that? 13 mg by 2 normal reaction. That is right, Siddesh. Get the second part, na? Right, Shreyansh. Got the first part. Get the second one. Let's see. First part, you should have got it. Let's see. 6.5 mg, 7g, 15 by 2 mg. Okay, looks like most of you are getting the same numbers. Let's see. Just now we saw this. You want to go to the highest point. You can use the result, or let's draw the FBD anyway. So what are the forces? The normal reaction which is pushing you down, your own weight mg, and the only person who is pushing you out is your centrifugal force. So normal reaction plus mg must be equal to mv square by r. Greater than equal to 0. Therefore, v must be greater than equal to rg. So the minimum speed at the highest point should be at least rg. This is what we derived. Means if you don't have at least this much speed, you won't even reach the top. This is state 1. This is state 2. Potential energy, mgh. I'm taking the ground as reference. Kinetic energy, 0. State 2. Potential energy, mg2r, the diameter. Kinetic energy, half mv square. Since the work done by external forces is 0, energy in state 1 is equal to energy in state 2. We get mgh is equal to 2 mgr plus half mv square. This is mgh is equal to 2 mgr plus half mv square. V square is nothing but mgr. You can clearly see h will be 5r by 2. This is your minimum. Anything more than this, you'll be safe. I hope this was clear. That was the easy part. What about the second part? Same picture. So you're at 30 degrees here. So let the ball be here. Now what are the forces? This will be the normal reaction. This is your mg. So this component will be mg sine 30. This is kind of like an incline. This will be mg cos 30. Any other forces? Yeah, you're going in a circle. So there'll be centripetal acceleration, which is v square by r. Since you're asking for accelerations, I'll do it in the ground frame. And don't forget, there's also a tangential acceleration. This is where most people forget. This ball is actually decelerating tangentially. The speed is decreasing. So you can clearly see mg cos 30 is providing you tangential acceleration. M into A tangential. So A tangential is g cos 30. That is one part of the acceleration. A centripetal is v square by r. So you want net acceleration. A net will be, it's a non-uniform circular motion. Root over A centripetal square plus A tangential square. I need to find speed there. We will do that. And what about the normal reaction? N plus mg sine 30 is providing your required centripetal acceleration, MAC. So normal reaction will be mva square by r minus mg sine 30. So there I need to find VA. That is the whole catch. This is my state 1 and this will be my state 2. And what will be this height? This height will be r. And since this is 30, this height will be r sine 30, which is r by 2. State 1 and state 2. State 2, my potential energy, mg 3r by 2. Kinetic energy, half mva square. Initial is equal to final. This will be mgh. Now remember, in the second question, it is given h minimum is 2h minimum. So h is 2 times h minimum, and we just calculated h minimum is 5r by 2. So this is 5r. So your initial potential energy is mg 5r. This will be mg 3r by 2 plus half mva square. This should give you VA is equal to, how much is this? And will get cancelled. 5 to 10 minus 3, 7 gr by 2, root 7 gr. Check. That is your speed. And then you have everything here actually. Once you got this, what is the A centripetal? A centripetal will be 7gr. A centripetal is 7g. G cos 30 is G root 3 by 2. If you do A centripetal square, A tangential square, this turns out to be root over 49 plus 3 by 4. That's 196. So that is root 199 G by 2. No? Root 199 G by 2. And this normal reaction will be mv square by r. This is 7 mg minus mg by 2. This is 13 mg by 2. Check your steps. Any doubts on this? Some people, they forget the A tangential. They take only A centripetal. It's a non-uniform circular motion. Your speed is changing at that instant. Have a look at the steps. This is how you can play around. Like, the only thing about vertical circular motion is at the highest point, you can't stop. You will have a minimum speed rho gr. Once you know that vertical circular motion is done, there's nothing there. Rest of the thing is like your regular work for energy conservation only. Clear with this? Let's see one more. Any doubts on this? Anything that you're not convinced here? FBD, energy, height, angle, anything? Clear na, Shihari? Pratyasha? Aditi? Clear with this? Sudiksha? Sudiksha, clear? Shaurya? Devanshi? Great, let's go ahead. Let's say we have a pendulum, length L. This point is fixed. Mass M. This is a string. You gave speed U is equal to root 4 GL. Means you are giving less than minimum. So this won't reach the topmost point. Find the position and velocity when tension becomes 0. So clear, the string won't reach the topmost point, it will become somewhere slack. So what is that point and what is the velocity then? Find h max of the particle. What is the maximum height reached by the pendulum? Let's get this. When I say position, the thing is, somewhere here it will become loose. So get me this theta. So if you can find the theta, you'll get the position. Somewhere at this position, tension becomes 0 and you will become slack. So at that point, I want you to find the theta. tan inverse 2. I don't think so, Reshman. How did you even manage to get tan theta? With 2 tan inverse 2. हो सकता है. Can you give me in sine? Which theta did you take? With the vertical or horizontal? Horizontal. Get me in sine theta now. Right, Samyak. You can give me with vertical or horizontal. Give me one of them in sine or cos. No, Reshman, that is wrong. You goofed up somewhere. Meaning, first of all, the moment you got a tan, that itself is somewhat little goofy. You shouldn't have gotten tan. You should have gotten sine or cos. Let's see. Velocity is fine. Give me H max. Ishman, nahi re. Why are you getting such good numbers? Right, Anvita. Something happened with Yushman. Let's see. You're doing some mistake. So somewhere here, you tension becomes 0. So I will take theta here. What are the forces? Tension will be inside. This will be mg sine theta. The centrifugal force will be mv square by L. So tension will be mv square by L minus mg sine theta. Since the tension becomes 0, I get V is equal to root over GL sine theta. That is 1. At this instant, let the speed be V. If you look at the total height, this height will be L sine theta and this height is L. This is state 1, this is state 2. State 1, your speed is U, which is root 4 GL. Potential energy, 0, ground frame. Kinetic energy, half mU square. U is nothing but 4 GL, so 2 mgl. State 2, potential energy will be mg L plus L sine theta. That is your height from the ground level. Kinetic energy, half mv square. Since work done by external force is 0, tension is there, but it is always perpendicular to displacement, so work done is 0. Energy in state 1 is equal to energy in state 2. Gravity is internal. So initial energy will be 2 mgl. Final energy will be mgl 1 plus sine theta plus half mv square, but v is nothing but gl sine theta. Mgl will cancel everywhere. This will be 1 plus sine theta plus half sine theta. This will be sine theta is equal to 2 by 3. If you have taken the angle from the vertical, it will be cos theta is 2 by 3. So that is also fine. Both are acceptable answers depending on what you have taken as theta. Nahi, Anvita. Till here you must have got it. Now most people will think, what is H max? They think the H max is L sin theta plus L. What most people forget is I need space here. Now, what you forget is this. Will the particle stop there? It won't stop there. The particle from here will start flying like a projectile. That means from this level, it will still continue to go up, isn't it? Did you get the catch? It won't stop at L sin theta. It will, after L sin theta, it will fly like a projectile. So you'll get this height also here. So the total H max will be this point here. This is your max height. The question doesn't get over when the tension becomes 0. This thing will fly like a projectile. Now try. So when I said maximum height from the ground, I never said the height when the tension becomes 0. It will continue to fly up. Right, Samyak, you got it. Right, Utsa, you got the velocity part also. Let's get the height, everyone. Velocity is fine. Get me H max. Let's see. Right, Ishman. So this thing flies off here. This is your speed V. V is root over GL sin theta. Sin theta is 2/3. So your velocity is root over 2GL/3. Remember, you have taken this is theta, and this is theta. So this is a 90 minus theta. So when it is flying like a projectile motion, this will be your H max. This is your L sin theta, which is 2L/3. And this is L from the ground frame. So the total height will be L plus 2L/3 plus that H max, which is U square sin square theta, but theta ka place may have 90 minus theta by 2G. This will be 5L/3 plus U square is 2GL/3. Sin square theta is 1 minus, that is 1 minus cos, that is cos square theta by 2G. 5L/3 plus L/3 cos square theta is 1 minus sin square theta, that is 4/9. That will be 5L/3 plus 5L/27. Multiply 9 there, 9 by 45, 50L/27. If you see, it is slightly less than 2L. If you had got 54/27, you would have got 2L. So you didn't reach the h max. The reason at the highest point your speed is not 0. You still have u cos theta. Don't forget that. So your height is slightly less than the 2L ka height. Yeah, right, Utsa, you got it. Vanshika, you got it. Any doubts on this? There, that's another good one. Let's see one last one for the day. This is fixed. This is a light rod. We have a particle of mass m. We have a particle of mass 2m. This is length L. This is length L. Remember, for a light rod at the h max, you can have 0 speed. Now, what you did, you kicked this thing with speed u. Two particles are attached to a rod as shown. Find u minimum so that it completes a vertical circle. Be careful, don't say root 4gl. That is derived for a single particle. Here I messed up the whole question. So this guy will go in a smaller circle. This guy will go in a bigger circle. Find the minimum speed of that 2m particle so that this completes a vertical circle. Let's see how will you handle this. These numbers are bad. Root over 4/3 root 20g by L by 3. Could be right. देखना पड़ेगा. I don't remember the answer. Ouch. What is the catch in this question, everyone? Do you think both the particles have same speed? We discussed this once, if you remember. Think about it. What will be same? Since it is a light rod, they'll have same angular velocity. You're getting it? They won't have same speed. The particles have same angular velocity. That means if this speed will be 2L omega, this speed will be u by 2, because this should be L omega. Both of them won't have same speed. And when this particle reaches this position here, this will be 2m, this will be m. Since it is a light rod, they will just come to rest momentarily. Since rod can push. Now look at this total height. This thing, so mass m has gone to a height of 2L, whereas 2m has gone to a height of 4L. So here I can write loss in kinetic energy is gain in potential energy. So what is initial kinetic energy? Of mass is 2m u square. So the mistake is that most people think m ka speed is u. It is not u, it is u by 2. And what is the gain in potential energy? M went to a height of 2L, whereas 2m went to a height of 4L. Bus. Once you figure that out, it is just one step there, and this would be mu square plus mu square by 8. That would be 10 mgl. This would be 9u square by 8 is equal to 10 gl. So u will be root over 80 gl by 9. Check. You can write 80 as 16, so that is 9. The 4 by 3 will come. That would be 5 gl. Got this? So just be careful. Whenever there's a light rods and you have more than 1 or 2 particles, they don't have same speeds, they have same omegas. Just be careful with that, and that's just fine. Clear with this? Yeah, right, Siddesh. Okay, with that, we'll wrap up for the day. So next class, when we catch up on Tuesday, we'll continue from here. We have few more models. Maybe I think the first half of the class, we should be able to wrap it up, or maybe we'll take time. If the chapter gets over early, we'll start off with center mass introduction in the next class. Okay, with that, we'll wrap up for the day. So any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you next Tuesday, same time. So take care, stay safe.